view, okay? So let's see. Let's come back here. Anybody need 22? Let's see. Javier, I think I heard you say something. Yes, 22. Definitely, Javier. We'll definitely go through it right now. So let's take a look here. And let me see if we can do a little copy and paste. It's not letting me do that. That's okay. If you go through here, go like this. And let's do this right here. Copy this, go like that. Copy this, bring this down. Come back over here. Okay, and I believe the directions for our problem said we're looking for the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. Okay, so we got 3 parts of this problem. A says, what's the sine of 2 theta? B says, what's the cosine of 2 theta? C says, what's the tangent of 2 theta? Okay, so notice what we have. We have the cosecant is equal to 25 over 7, and it says cosine is positive. Okay, so guys, remember how we define cosecant? Cosecant is defined as the hypotenuse over the y value, right? And so in our case, we know that our cosecant is 25 over 7. So what this is telling me that is my r is 25 and my y is 7. What we don't know is what is our x value, right? So remember, basic Pythagorean theorem y'all says x squared plus y squared equals r squared, right? So look, we're going to have x squared plus y we said is 7 squared equals 25 squared. Okay. 7 squared, y'all, is 49. And 25 squared, I want to say, is 625. Boom, 625. And so now we're going to go ahead and subtract 49 on both sides. So let me take 625 minus 49. And I'm coming up with 576. And so now I need to take the square root with my calculator. Here we go. Second square root of our answer. We're coming up with 24. Okay, so guys, notice what we're doing here. When I get to this step, I'm really taking the square root on both sides. The question is, am I going to use the positive square root? Am I going to use the negative square root? When I come back to my original problem, yeah, look what it's telling me. It's telling me that the cosine is positive, right? So remember how the cosine is defined? The cosine is defined as what? X over r, right? Guys, r is always going to be a positive number. R, the distance or hypotenuse, is never going to be negative, okay? So if the cosine is positive, and I already know that r is positive, then the x value is also going to have to be positive. That's why from here, I stopped at x is 24, not negative 24, okay? All right, so now that we know that, let's go through each of the pieces. Part A says we want to find the sine of 2 theta. Anybody remember the formula? There you go. Okay, so let's do it like this, 2. All right, if we know that the sine of theta is y over r, wouldn't that be, and we know what y is, we know what x is, and we know what r is, we would say the sine is going to be y, which is 7 over 25. Cosine is going to be what? 24 over 25. Man, I could have stayed home. You already know what to do. All right, so look, 2 times 7 times 24. I don't know. The bottom is 625. Let me do the top part. We're going 2 times 7 times 24. 336. And I cannot reduce that. So there's my sine of 2 theta. Okay. Then we're going to do cosine of 2 theta. Okay, so let's do cosine of 2 theta. Now this one we had different formulas. Anybody remember one of them? Good, man. Cosine squared, very good, y'all. Minus sine squared. Okay, we already said cosine squared was 24 over 25 squared. Sine we said was 25 squared. Okay. So what's 24 squared? 576 minus, I know 7 squared is over 625. So 576 minus 49, 527. There we go. So here's my answer for cosine of 2 theta. And then the third part, y'all, was asking us for tangent of 2 theta. And I want to say this was it 2 tangent theta over 1 minus tangent squared? Okay. So let's see. And I'm going to try to write this a little bit bigger so y'all can see. Here we go. Tangent of theta is y over x. And we know our y value is 7 and our x is 24. So tangent of theta is 7 over 24. Okay. And so now we're going to say this is 2 times 7 over 24 over 1 minus 7 over 24 squared. Okay. So, y'all, I'm going to go super slow here. 2 and 24 will reduce. So that's 7 over 12. And then this is going to be 1 minus 49 over, we did 24 squared a little while ago, and we got 576. Okay. So then this is 7 over 12. I can think of this one. Very good. Excellent. And did we do 576 minus 549 earlier? Yeah, 527? That's what you were saying, right, John? Over 576. And then what do we got to multiply now, y'all? Reciprocal. So 7 over 12 times 576 over 527. And y'all, I'm just going to do this on my calculator because it's going to be so much easier. Let me go like this. 7 over 12 times 576 over 527. And hit my answer. And let's see if we can convert it back to a, oops. See if we can convert it back to a fraction. 336 over 527. And okay, that was just an email that came through, but probably nothing important because it never is. All right, so guys, let's go ahead and put our answers in so we can make sure that we're good. So the first one we came up with was 336 over 625. 336 over, what was it, 625? Second one we came up with was 527 over 625. Let's go like this, 527 over 5. And the last one we came up with was 336 over 527. There we go. 336 over 7. Yeah. You didn't have to go that way. Because think about it this way. You can replace that 2 theta with anything you want, right? And isn't the tangent of my angle defined as the sine over the cosine? There you go. So we got it. Let me come back over here. And Javier, I know it's going over. I know it's going all crazy on the screen. But did that make sense, Javier, on how we did that one? RV, good. 22. Yeah, we're good. We're good. Awesome. Good. Double checking, making sure we're good here. Let's go ahead and continue, y'all. And let's see. What do you think? Y'all want to do this one? Y'all tell me. Let's do it to it. Okay. Let me do a little copy and paste. Okay, we're going to verify the identity, copy it. Was it? Oh man, how's that? There we go. Okay, so we're going to go super slow here. Yeah, we're going to convert a lot of stuff, right? So remember what we're going to do, y'all. We're going to fix everything because. So the first thing I would say is, if you look here, we have 2 thetas, and our answer at the very end only has what? 1 theta. Okay, so we want to make sure we don't write anything with 2 thetas. Okay, so a little while ago, y'all told me that this was sine theta, cosine theta, right? Okay, over 1 minus. Now, we had different formulas for cosine 2 theta, didn't we? So for cosine 2 theta, y'all, we had cosine, we had cosine squared theta minus sine squared theta, and then, do y'all remember the other ones? Oh, anybody? Okay, so look, we'll go like this. Yeah. Guys, just a heads up, I did send you guys another email with the new fundamental identity handout. So we added, remember we added all those other things to it, right? Like we added the unit circle and we added all this kind of other extra stuff that we thought would be helpful. So let me come back to the double angle. Here we go. This is what we're looking at. Okay, so we have these other 2 right here, 1 minus 2 sine squared and 2 cosine squared minus 1. So 2 cosine squared theta minus 1, and the other one was, what, 1 minus 2 sine squared theta? Something like that? 1 minus 2 sine squared theta, I think that's what it was. So 1 minus 2 sine squared theta and 2 cosine squared theta minus 1, right? Okay. All right, so guys, this is what I'm going to do. I'm looking at this part right here, and let's see. I'm going to try using this one, right? I'm going to try, it doesn't really matter which one I use, but I got to use at least one of them, okay? I'm going to try using that one. So look, 1 minus, I'm going to put this part in parentheses, 1 minus 2 sine squared theta, right? Okay. So now, yeah, this is going to be 2 sine theta cosine theta over 1. I'm distributing that negative. That's going to be minus 1 plus 2 sine squared theta. Okay. Yeah, so 2 sine theta cosine theta. Those are going to cancel. I can think of this part right here as 2 sine theta and another sine theta. And then the 2's are going to cancel. The sines are going to cancel. We're going to end up with a cosine over a sine theta. And that's the same thing as our cotangent of theta, right? Okay. So this is how we wrote it out, right? I'm just writing this like it's on paper. Let's come back to our problem, figure out how we're going to do this deal, right? So if I come back here, y'all, look at the first thing we did. We used double angle formulas, right? So let's come back over here, and I'm going to put a fraction first. We're going to say 2 sine theta cosine theta over 1 minus parentheses 1 minus 2 sine squared. Like that. And what do we use? Double angle. Boom. There we go. Let's validate it. Okay. And then we come back to my paper. Okay, what do we do next? we did some algebra. So guys, what I'll probably do is I would probably write, I don't know, this right here. Okay, so let me try doing that. Nicole? Okay, so I'm going to go 2 sine theta cosine theta over, what do we have on the bottom? 2, and then 2 sines? And this was algebra. Validate it. Okay. And then now I'm going to cancel my 2's and cancel my sines. So I'm going to write cosine theta over sine theta, cosine theta over sine theta. Isn't this still algebra? Because all we're doing is canceling stuff out. There we go. Validate it. Okay. And then cosine over sine is cotangent of theta, and that is the quotient rule. We're going to validate it, and we got it. Okay. Check it. 12. So good that we did it, right? Excellent. Let's take a look here. Let's go to 24. Okay, what do you think? Y'all tell me. I'm just here to answer your questions. So we got plenty of time. We got an hour still. Almost an hour for class. You want me to do it? Yeah, let's do it. I would say unless this is something we know, like you can do it off the top of your head, I say let's just do it. Write as the product. Write the product as a sum or a difference. So look, I'm going to come back over here. Let's paste this thing in here, right? Here we go. Okay, so look, it's telling me, what I like about the problems, y'all, is they're telling me exactly what to do. Write the product as a sum or difference. So I'm going to come back to my, this deal right here, my formula sheet, right? Write the product as a sum or difference. Okay, so look what it is, product to sum formulas, right? This is what we're kind of looking for. So when I pull up the problem, we have sine of one angle, sine of another angle. So wouldn't that be this right here, sine of this angle, sine of that angle? Okay, so let me see if I can do it like this. I'm just kind of copying and pasting here, y'all, because it's going to make it easier when we do it over here. So let me copy that. Come back here. Let's paste this. That's what we're looking at. Okay. So, guys, if I do a little stare and compare, you all agree that's my U and that's my V? Okay. So look, let's see if we can write this out. We're going to write out 1/2 cosine of negative 4t minus 9t minus cosine of negative 4t plus 9t. Okay. So this here is going to be 1/2 cosine of, isn't that negative 13t minus cosine of 5t? Okay. And I would probably stop. Got to put the brackets right here. I'd probably stop right there. If I was going to go further, the only other thing that I would do would be this. And so, hold on real quick. This part right here, y'all, and I'm just gonna zoom back to my formula sheet. Here we go. Let me come back to my formulas. Yeah, this one where I had the even and odd, where it says the cosine of my negative angle is this the cosine of an angle. That's probably the only thing I would do, right? Using even and odd identities. So look, let's do it this way. Let me come back to my problem, right? And I'm going to try entering it in like this way first. And if it doesn't work, then I know I got to do that part. You know what I mean? Or I can just, let me just enter this part in because I'm using, again, one of the identities. I'll tell you what. Let's just go this way because we just used an even and odd identity. So 1/2 cosine of 13t minus cosine of 5t. Okay, right here, we're going to go 1/2 parentheses, oops, not there, but right here. Cosine of, what was it, 13t? Oops. Minus cosine of, was it 5t? T, boom, tickety check. We got it. Right. So again, what I want to point out is, like I said, guys, in doing the problem, and I'm going to come back to the original problem right here. What I like about the problem, it told me exactly what to do. Write the product as a sum or difference. So that's why we're able to come back to our formula sheet and say, look, right here, here's the product to some formulas, right? Or different formulas, right? It's all right there. Okay, let's go to 25. Let's take a look here. 25. What do you think? You want to do? Or are we good? Same thing? What would be the first thing I would do with this problem, y'all? What do you think the first thing I would do is? I'd convert them to degrees, right? I'd convert them to degrees. Okay. 26. Okay, y'all want to do 26? What do you think? Y'all let me know. I would definitely use a chart for this one, right? So are we good, or do we need to do it? We're good. 27? Same? Okay. 28? What would I do with 28? Wouldn't I just solve this by isolating what? Getting the cosine by itself, moving that over, dividing by 8, and going from there, okay? I'll tell you what, let's go ahead and do it just to make sure that we're all good here, okay? So look, we're going to go like this, copy, come back over here. Let's go right here, paste. All right. Solve the equations, write the numbers using integers or simplified fractions. Okay, remember what we're trying to do? We're trying to get this guy by itself. So we're going to take this piece and we're going to move it over. When we move it over, what kind of 4 square root of 2 does it become? Negative. Then aren't we going to divide both sides by 8? All right, so what I'm going to do here, can't we reduce negative square root of 2 over 2, right? Okay, and then what we're going to use is what now? How do we get to our x from here? Yeah, we're going to use the chart, right? So we're going to come back to this. Where's my identities? Here we go. We're looking for the cosine, so it's this one here. When is it equal to the negative square root of 2 over 2? At 135, and where else? 225, okay? So 135 and 225. So at 135 and at 225 degrees, right? These are in degrees, okay? So now we got to convert these to radians. So remember, we're going to go 135 over 1 times pi over 180. Same thing here, we're going to go 225 over 1 times pi over 180, okay? So this is going to be 135 pi over 180. We're going to write that as a simplified fraction by using our calculator. So again, I'll just go 135 over 180. 0.75, which we know is 3/4, right? And then the same thing here, this is 225 pi over 180. And John, you said that was 5/4? It's not that I don't trust you, I just want everybody to see the calculation. Very good. 1.25, 5 pi over 4, right? Okay, so now when I come back to the original question, right, which was right here, over the interval from 0 to 2 pi, we came up with 3/4 pi and 5/4 pi, right? So 3 pi over 4. on the 5 pi over 4? Check it. And we got it. Okay, now we're looking for the set of overall real numbers, right? So guys, first thing I'm going to do, I'm going to come back to my original problem, which was right here. Okay. Anybody know what the period of this function is? Period is 2 pi. Okay. So these answers are going to occur for multiples of 2 pi, right? So we're going to go plus 2 pi n plus 2 pi n for our general answers. So again, we'll come back. Oh, is that how they're writing it? Does it make any difference though if I put it the other way? Let's try it. Let's go 3 pi over 4. Oops, over 4, not like that. Plus 2 pi n. And the other one was 5 pi over 4. Plus 2 pi n. And you said they were writing as 2n pi? Is that how you said they wrote theirs? Let's just check. Boom, and we got it right. So it's not necessarily that you have to do for all 4 quadrants. It's that when like, I sent out a video on Friday, right? And part of it was the period was different. So the period was not 2 pi, but the period was like pi or something like that, I think, when I said out on Friday. And so for that one, when we're doing it over the interval from, because those, we were actually putting the general answer first, and then we were doing the interval from 0 to 2 pi. So because the period was pi, these things repeat over every multiple of pi. So when we're going to do it over now for 2 pi, now not only are we going to have these 2 answers, but now we're going to have another pair of answers because they're occurring on that second interval from pi to 2 pi. So sometimes you end up getting more than just the 2 general answers like we got over here. But that's when that happens. When the period is not just 2 pi. The what? Say it again now? Oh, like reflections, symmetric?
Yeah, what's on the terms for y and then over the x?
So they're symmetric about the x-axis and they're symmetric about the y-axis. Yeah, no, that's it. So hold on, let me hold up real quick. Javier, are we good on all these problems that we went through today? I'm going to stop sharing the screen real quick because it looks kind of messed up. Let's stop that part. Did these other ones, oops. They have to get back to us. And guys, since we've done the problem